Welcome back, everybody, to this fascinating journey through the universe. Today, we're counting down the top 10 most incredible exoplanets, from a planet made entirely of diamond to planets that orbit two suns. These worlds are going to blow your mind. Join me on a journey through some of the most unusual, weirdest planets in the universe. Make sure to stay tuned until the very end. You would not want to miss this cosmic adventure. So let's get this started. 1. WASP 76 bits, the exoplanet that rains molten iron. Spotted in 2013 and further investigated by the ESPRESSO instrument on the Very Large Telescope in 2020, WASP 76 bits is a planet that is tidal-locked to its parent star BD plus 01316. This means that one side of the planet permanently faces the star, causing scorchingly hot temperatures of around 4,532 degrees Fahrenheit, 2,500 degrees centigrade, hot enough to vaporize iron. The star-facing side of WASP 76 bits is roasted by radiation that is thousands of times more intense than that Earth receives from the Sun, while the side that faces away from the F-type star experiences perpetual night. Yet even though the day side of the planet experiences hellish temperatures, that doesn't mean that conditions on the night side are a walk in the park. The side of WASP 76 bits that faces away from the planet's parent star is cooler by at least 1,832 degrees Fahrenheit, 1,000 degrees centigrade. But this means that when iron vapor is carried across the hemisphere by powerful winds, they are cooled, forming liquid droplets. 2. HD 189733 bits, showers of molten glass. From space, HD 189733 bits may appear to be a beautiful and tranquil world, resembling a giant glassy blue marble. With exoplanets, though, appearances can be deceptive. And this definitely the case for this gas giant planet that completes an orbit of its star in just 2.2 days. In fact, its beautiful blue hue arises from its deadly weather, particularly the molten glass rains that pelt the planet's surface. Yet this isn't the extent of the planet's almost maniacal weather conditions. The exoplanet, discovered in 2005 by both NASA's Chandra X-ray Observatory and ESA's XMM Newton's X-ray telescopes, also experiences winds of around 5,600 miles, 9,000 kilometers per hour. These supersonic winds cause the exoplanet's glass rains to arc sideways towards the ground, rather than just falling, also picking up silicate particles, turning them into microscopic projectiles. 3. Gliese 1132 bits, the planet that grew a second atmosphere. Gliese 1132b is similar to Earth in a striking number of ways. Its radius is only slightly larger, as is its mass. Even its age, 4.5 billion years old, is similar to that of our planet. But this world does have one striking difference. It orbits much closer to its red dwarf parent star, completing an orbit in just 1.6 Earth days. This proximity results in Gliese 1132 experiencing a much higher surface temperature than our planet at 278 degrees Fahrenheit, 137 degrees centigrade, with the intense radiation stripping the exoplanet's atmosphere. Yet, astronomers have recently discovered that something extraordinary is happening on Gliese 1132b. The gravitational influence of its star, 20% larger than the Sun, creates intense tidal forces that squeeze and stretch the planet. This flexing gives rise to violent volcanic activity and causes gases to rush to the world's surface. 4. Kepler 10 bits. In a galaxy far, far away, Kepler 10 bits orbits close to its host star, similar to the Sun at a distance that is a 20th of the orbit of Mercury. This results in an orbit less than an Earth day and a surface temperature hotter than 2,372 degrees Fahrenheit, 1,300 degrees centigrade. Because Kepler 10 bits, discovered in 2011 by the Kepler telescope, is tidally locked to its star, it also creates molten droplets of iron and silicates. The planet's surface is likely covered with lava much hotter than that found on Earth. because the harsh radiation from its host star has stripped away its atmosphere. These droplets on Kepler 10 bits won't fall on the night side of the planet, are instead blown clear of its surface by stellar winds, giving it a fiery tail. Kepler 10 bits isn't the only lava world discovered by the Kepler telescope. In 2013, the Space Telescope also found the exoplanet Kepler 78 bits, 40 times closer to its host star than Mercury, that completes a full orbit in a matter of hours. 5. Upsilon Andromeda, a world of fire and ice. Upsilon Andromeda is another exoplanet that is probably tidally locked to its host star, completing an orbit in just under 5 days. What makes this planet, which was previously known as Sapphire, an extreme world, is the radical difference in temperature between its dayside and nightside. Whilst the dayside experiences temperatures as high as 2,912 degrees Fahrenheit, 1,600 degrees centigrade, the night side is considerably cooler, reaching temperatures as low as -4 degrees Fahrenheit, -20 degrees centigrade. This means that passing the hemisphere of this world could be considered equivalent to jumping into a volcano. While this is by no means the only tidally locked hot Jupiter, the others we have discovered don't seem to feature such radical disparities in temperature between their star-facing and star-ignoring sides. 6. HR 5183 bits, the Whiplash planet. In terms of exoplanet discoveries, HR 5183 B's super Jupiter, 3 times the mass of the solar system's largest planet, is unique, as its orbit is highly eccentric, both literally and figuratively. While most planets trace out a mostly circular orbit, this gas giant traces out an egg-shaped orbit around its parent star HR 5183, according to astronomers at Caltech. Astronomers discovered the exoplanet by the tiny wobble its gravity causes upon its parent star, which in turn causes a dip in brightness. The process took a staggering 20 years of observations with 3 telescopes, including Hawaii's W.M. Keck Observatory. Despite this long period of observation, we are yet to see the world complete a full orbit, with researchers estimating that this could take between 45 to 100 Earth years, probably 74 years. 7. Ogle 2016 BLG 1928, going rogue. Astronomers believe that the Milky Way could be teeming with cosmic orphans exoplanets that have broken free of their parent stars to wander their galaxies alone. These planets are believed to form in traditional ways around stars, but are later flung away by gravitational interactions with other planets. Because exoplanets are usually spotted through the effect they have on their host stars, this makes these homeless planets almost impossible to spot. This is especially true when they are Earth-sized rocky planets. That's what makes the discovery of the rogue exoplanet Ogle 2016 BLG 1928 as it wanders the Milky Way so special. While it isn't the first rogue planet to be discovered, it is the smallest, with other examples much similar in size to Jupiter. The rogue terrestrial world was spotted in late 2020 using a technique called gravitational microlensing, the deflection and focusing of light from a distant star as an object passes in front of it. 8. The TOI 178 system, a system of harmony and chaos. At first glance, the planetary system TOI 178 may look like any other set of worlds. But a closer and more prolonged observation reveals that at least 5 of this system's 6 worlds are locked in a rhythmic dance with each other. The 5 outer planets exist in an 18:9, 6:4, 3 resonance. This means the first exoplanet in the chain, the second closest to the star, overall completes 18 orbits, as the second in the chain completes 9. The third completes 6, and the fourth completes 4. And the fifth, the 6th planet overall, completes 3 orbits. This means that the planets align at regular intervals as they orbit their orange dwarf host star. This complex chain of resonance likely indicates a planetary system that has remained undisturbed by gravitation interactions or collisions with other systems since its formation. 9-55 Cancri E, the universe's most valuable exoplanet. Another star that orbits close to its host stars, taking under 18 hours to complete an orbit, 55 Cancri, is also inhospitably hot, reaching temperatures as high as 4,172 degrees Fahrenheit, 2,300 degrees centigrade. But what really sets this world apart is its composition, which makes the exoplanet, formerly known as Janssen, perhaps the most conventionally valuable object in the universe. The fact that 55 Cancri is twice the size of Earth, but has almost 9 times the mass, led astronomers to propose that this super-Earth could be composed of high-pressurized carbon in the form of graphite and diamond mixed with some iron and other elements. According to NASA, the estimated value of 55 Cancri is estimated to be 384 quadrillion times more than Earth's entire gross domestic product, GDP, which was valued at $70 in 2011. 10. Planets. Black holes, extreme exoplanets. The most extreme exoplanets may not form around stars at all, but instead could orbit supermassive black holes. Planets form from the gravitational collapse of overdense areas of protoplanetary clouds of gas, of dust, and supermassive black holes at the heart of active galactic nuclei, AGN, sit at the center of massive churning disks of such materials. Currently, there is no evidence that such black hole orbiting planets or planets actually exist, but recent research modeling the dynamics of these disks of gas and dust does suggest that under certain conditions planet formation should occur in such regions. Should such processes occur, planets would form much further out from supermassive black holes than most planets do from their parent star. Thanks for joining us on this epic ride through the most amazing exoplanets in the universe. We really hope that you enjoyed the ride of discovering these unique and out-of-this-world places as much as we did. If you like this video, then don't forget to give it a thumbs up, hit that subscribe button for more amazing content, and let us know in the comment section below which exoplanet blew your mind the most. Your support keeps us going back out into the cosmos. Keep an ear out for more space adventures. Keep looking up.